As we are, hey everyone, welcome. This is our next episode of the Cathode Road podcast. I'm here with Steve, and we have the pleasure this time of being joined by the creator of the Open Source CRT project. It's been getting a lot of coverage lately, and it's an extremely interesting thing. We want to welcome Thomas Daede. Thomas, how are you? And thank you for joining us.
Oh, good morning from my time zone. Doing good today.
Nice, real good. So, Steve and I will say we're fascinated by your project. We're just a couple of nerds as well who just want to ask you questions and be like, "That's cool, tell us more," sort of thing. And I think let's we want to learn more about you. Who is this guy, right?
Yeah, well, I mean, first off,
Steve.
First off, thanks again. I mean, this is just a. So Lewis and I don't know, it must have been a couple weeks back. We got the clip that you had put out of your project, and then we'll add a link to that clip here so anybody can check it out. But I saw this clip, and I was just blown away by the clip, and it's just like I obviously wanted to know more. I talked to Lewis, and he's like, "Oh yeah, I had seen that too." So I loved just what I saw from that little clip. And then, like I said, we were privy to some insider information and got to preview your interview you did with Bob at Rgb, which was awesome. But if you don't mind, maybe you could take us just on a couple minutes here, take the floor and explain a little bit about your project, what it is, and whatever you really want to do to say, introduce it.
Yeah. So, it's the repository is a TD CRT. It is I call it an open source CRT. It's also better known as maybe a CRT chassis. I don't really like the name chassis because for non-CRT enthusiasts, it's kind of a weird name. But it is basically all electronics for a CRT monitor minus the CRT glass itself. So you do have to provide some existing CRT tube, but then you attach my electronics to the rest of it, and it becomes a complete new monitor.
Excellent.
Very interesting. It's super fascinating and it invites so many questions about how the fuck does one come in their life and their interests and to be so talented at this that they could conceive and make significant progress in building this. So, Thomas, first of all, where did you grow up? I mean, in the United States, where did you grow up? And I don't know, I want to start from this because I think there's something interesting here.
Yeah, so I mean, I grew up in Rochester and Minnesota, which is where I am right now. But I think I have a bit of a weird history in terms of, I guess, what I do. I mean, my day job is video compression, which is sort of related.
Okay.
But I previously also worked on power electronics. I was on the university solar car team where I did work on the motor controller and inverter. Technically my degree is in specializing in power electronics, I guess. So I guess I had video and power electronics as background. Not that that really, I mean, it helped me sort of, but the knowledge for CRT chassis was, something that is not really taught in school. No one makes CRT monitors anymore. Yeah. So it's not even the knowledge on the internet you can find is somewhat limited. So it was.
I mean, it's fine. I think it speaks to you. First of all, how does one even in this lifetime come across such information? And okay, sure, that's interesting. That's your background. Sorry, Steve.
No, you're fine. Yeah, that I can see a little bit on how that would make sense on being involved somewhat with power. And you'd have to have some kind of a expert level knowledge to begin with to start tackling just some of the amazing issues I heard you talking about with Bob that we'll get into a little bit more. But just so we're a little bit clear on everything, this is electronics that are meant to replace, from what I understand, everything on your CRT besides your CRT tube, your deflection yoke, and then also the flyback assembly with the anode, and then also it can be helpful to have the neckboard. Is that correct? And then your open source would go in and kind of adapt the rest so that you could use your process in the place of that?
Correct, with the exception that I also replaced the flyback. I don't use the original flyback.
Oh,
So my
okay.
demo was using the original flyback. However, that's not really my end goal. So I already have a separate circuit board that also replaces the flyback. Um, yeah.
Wow.
Uh,
Dang.
Okay.
so that's not entirely necessary. You can reuse the original flyback, and basically it works. Just you set up the original chassis to run on its own with just a fly, and you only use the flyback part. So that works. It's just kind of, I would like to, if I have the entire chassis in there only for one component, I'd rather just drop that entirely.
So, so if you can, just right off the top of my head here, if you can get rid of of the flyback, are you still having to make the same high frequency power that would emit the sound that the flybacks emit?
Yes. So
Okay.
so I do use a flyback. I use right now my design uses a Wells Gardner K7000 clone flyback because those are readily available as replacements. It just
Right.
happens to be the most widely produced one. Um, Flybacks are actually still manufactured. They're manufactured for powder coating guns and as neon sign transformer power supplies. Often still, they look like a CRT.
Oh.
They have the same CRT mold and plastic and everything. But
Huh.
because they're still made, I can still get new parts. But yeah, so the it doesn't have to wind at, so a CRT winds at 15 kilohertz normally because that's the horizontal scan rate for 240p. So there are two sources of the wind. One is the flyback, and one is the horizontal deflection yoke. So when I'm running in 240p, I can't eliminate uh, the 15 kilohertz wind from the horizontal yoke. But I can eliminate the one from the flyback because I can run the flyback at a higher frequency. So it does run quieter.
That's pretty amazing. I mean, just that sorry, that just like came to me out of nowhere. I was like, that's a really cool feature, I think. But yeah,
Yeah. Thomas,
did
how
that
long have you been working on this to get to this place then?
It's been a project for about 2 years or so now. I've worked on it on and off. It's a very frustrating project to work on because there are a lot of things to go wrong. It's just relatively difficult to work on. Whenever I get, I'll
Mm,
drop it for a couple months and pick it up again.
sure. So what was the first sort of spark in your mind that, okay, I mean, look, you've got some skills in power, you know what's going on, you've got an interest in this hobby, and at some point was it what fascinated you about this challenge? Was it a technical, like, or just a practical, or what sparked you?
I think there are two things. One is that I did a lot of repair on arcade CRT chassis, and they were really frustrating because the many of the things we had to fix were basically the self protection circuits kicking in on the chassis because there are basically there's a lot of self protection circuits on most monitor boards. Basically, if there's something fails, they'll turn off before they blow themselves up or burn a line through your monitor or whatever. So
Right.
they'll turn off, and then you'll have no idea what to do. So if there's a little chip on there, often a microcontroller that has different outputs for the faults, and if we had documentation on those, it would be easier to figure it out. But we don't for most of them, and I was very frustrating debugging everyone else's design, and I really wish I just had my own design that I made, and then it could have tell me what's wrong over serial or something, right? Print a nice error message.
Mm,
Um, the other motivating factor was
dang.
that I have a Aero City, which is a kind of a candy cab arcade cabinet, and its internal monitor is 15 and 24 kilohertz only. I really want to run it at 31 kilohertz because that allows me to play some newer games like Naomi and Exa games, for example. So I kind
Mm.
of wanted to upgrade it to support 31 kilohertz.
Dang, I wonder. Holy shit, dude! You looked at a CRT and said, "Nah, it's 15 kilohertz, 24 5. I think I'll mod it." I'm like, I like that. I like that idea that
not just mod it, have to redesign it to
the
get
whole
to even
thing.
do that. So you said that you like so was that a job that you had working on like arcade monitors, or was it something like that you did for your own collection? Can you give us a little bit of a history on that?
Yeah, I mean, and I don't do it as a paid service, but In California, there are quite a few basic home arcades and the like that have many tubes, and a lot of them are breaking all the time. So I often end up fixing them, or at least working on them.
Okay, just friends and things like that.
Yeah,
Like people
exactly.
you know,
Yeah,
and
that's
somehow you got
that's
connections
been
in the
a
community.
just knowing enough people. It has yielded more broken CRTs than I can ever handle in a lifetime.
Everybody's got a broken one, don't they?
Yeah.
Give you. You like these things, right? That's what I get a lot. You like these right before they're ready to throw them out in the curb.
Right. We're the ones that deal with stuff that people want to leave on a curb, and we're like, no, we think we can do something with it.
Well, I was just gonna jump in and say I thought that was one of the great maybe futures for your design and product altogether. The fact that you are dependent on reusing the tube, because there's no there's no way to really properly dispose of a CRT tube that's environmentally conscious and friendly. And the best way would be to figure out a way to reuse these. And, that's what I was laughing with Lewis. I was like, maybe we could see a future where CRTs are back because they have to be reused as a point to just throwing them, in heaps and piles.
Right.
And
What do you think
landfill.
about that, Thomas?
My main motivation for these is for basically, retrofitting arcade machines. Obviously, like the console gaming also works, but arcade machines, their tubes have been run for 30 years plus. They're really, really worn out at this point, and it's kind of frustrating because I see TVs thrown out on the curb all the time that have the same exact tube or a very similar tube, but the yoke is wound slightly different and they're unusable as an arcade monitor. But with small electronics changes, they would work just fine. So there's a big a big untapped source of perfectly good tubes that aren't usable because of their electronics.
When you were beginning the project, where did you, begin with? Did you start? Literally, even the first bits, did you start tapping into the neckboard, and then okay, now I can fire off here, or where did you have to slice this up from?
Yeah, so I actually started with a PVM 1390, which is a kind of an 80s desktop 15 kilohertz computer monitor, and that one is really easy to work on because if you open it up, it's all split into nice little modules. So the very first thing I did is the AC power goes in and it gets converted into a 12 volt logic supply and a 120 volt DC B plus supply. And so the very first thing I did is just unhook its power supply and run it off my own bench supply.
All right, yeah.
So then I could make a 12 volt and a 120 volt power supply that could run it. Then I basically started unhooking things and running them myself. So the very first thing I wanted to work on is deflection. So I made a whole big PCB that has everything on it, and that's what I showed. It's just one big chassis PCB, and that had horizontal. It has everything on it, but the first thing I ran was horizontal and vertical deflection. In fact, vertical deflection first. So for vertical deflection on many monitors, including that one, and also the 9-inch one I used later, if you unhook the vertical deflection yoke, it'll just run and it'll collapse, right? You'll see just a line. So, but it doesn't have protection against that. So I can just unplug the vertical, plug the vertical into my chassis, split the sync so it runs to both chassis at the same time, so they both are happy and run. And I can just replace the vertical deflection with my own. Then I did the same thing for horizontal.
Right, piece by piece.
Yep. Horizontal, you have to put horizontal won't run without the horizontal connected, so I used a small inductor that's the same inductance as the horizontal yoke and hooked that up to the original chassis so that the original chassis would continue to run. And then, so I replaced horizontal. Then the last thing I replaced was the Rgb amp because I was originally using this built-in RGB circuit from composite video. And I switched it to my external RGB amplifier. And even later than that, after the demo video, I ran it also on my own high voltage as well. So I split the high voltage out and ran my own, which I don't have a video of yet. But
it's
awesome.
It's
I think
so
it's
cool.
just like the coolest sounding thing. This is literally like a dream that I didn't really ever think that anybody would be able to come along with and really address some of these things. If you don't mind, I had a couple things that like I wanted to kind of follow up a little bit on kind of the ways that you were telling us how you kind of step by step went through, and maybe because I was listening to you, and I've worked on a ton of CRTs, and my thing has always been like you were just talking about, repairing, diagnosing, trying to figure out, again, like you said, what safeties are kicking in because something else has failed on the monitor, so it's preventing the rest of it from turning on. So but the actual thoughts of jumping in and thinking you could, come in and replace a lot of these systems. I was just hoping, I heard you speak to some things I thought were so really cool in your other interview. One of those specifically being on how you went and got around from having to use the hot, right? And you were able to go and start using MOSFETs. Is that correct?
Yeah.
When I thought I heard that.
So like the horizontal deflection transistor is one of the biggest parts of a CRT in it.
Right.
On a lot of CRTs, it runs not only the horizontal, but it also runs the flyback. And so the flyback provides the high voltage, it provides focus, it provides screen. On a lot of them, they'll also provide like all their auxiliary voltages off the flyback too, because it's a convenient transformer, right? Like sometimes like the speaker amplifier will be powered off the flyback, whatever else. So that transistor has a lot of load on it. And in particular, it's exposed to very high voltages. It's exposed to, usually on a lot of monitors, it's exposed to around 1,000 volts. So it has to be relatively robust. And previously, they were specially designed BJT transistors that were used. And you can actually still buy them. There's one or two that are still made, and you can buy them off DigiKey. So that is an option. But luckily, because there's been a renewed interest in high voltage power electronics, well, maybe not a renewed interest, because they've always been interesting, but they get used a lot for things like electric cars, right? Because electric cars will have 400 or recently 800 volt battery packs that are, very similar voltage ranges they need to deal with. Trains run off 600 volt DC catenaries, like for like light rail and stuff. And so there's been a lot of development on power electronics in that voltage range. So there's both IGBTs and silicon carbide MOSFETs that have more recently been developed for those applications. And I can, of course, use that on my 1,000 volt rail too. They're obviously a little bit overkill, some of them, because I'm not running a whole train, but
But you could take advantage of that newer technology, and right, it's got a much higher tolerance, and it doesn't. Were you saying that it runs? It's just not because that I know that in my dealings with that part, it runs exceptionally hot normally too.
Yep.
Obviously, like so much voltage, and so you don't have the same temperature problems, right, with this
design.
Right.
In fact, I run it without a heatsink at all. It just sticks up from the board, just floating there, and it gets about a degree Celsius above ambient. Yeah, it doesn't. It's extremely efficient. In fact, on the next revision, I'm switching to a little small surface mount version of it because it doesn't even need to really. But yeah,
Wow.
it's also a lot easier for me to drive it because MOSFETs can just take silicon carbide needs usually a 20 volt gate drive, but BJTs take a quite high current gate drive, so they also have a little dedicated transformer just for the base drive usually of the BJT based hot, and I can eliminate that component with the silicon carbide MOSFET.
So that's really cool. That actually it's funny. That was, you were talking about that, and it fell right over into where I was going to go with the flyback, because you'd mentioned that the flyback and the focus and all that was kind of interconnected in a lot of these CRT designs. So yeah, and then like also with I guess when you're going through this, I know you were basing it around, you said the single flyback, but is there a specific tube or television, something that this will work better with, or exceptionally well with? I guess what I mean is there a variation in things like the deflection yoke that would yield better results, or a certain tube that you should be
Yes.
wanting as a compared to another?
Yeah. So the
Okay.
my base model my reference model tube that I've kind of been using for when I make design choices is like the MS829 and MS9 monitors. They're 29-inch tubes, arcade style, designed for up to usually 24 kilohertz. The These tubes have all pretty much very similar yoke connectors, yoke impedances. They all use the exact same connector on the back of the CRT. That connector is all the same, which makes them really convenient. But I can support a bigger range than that. Of course, I'm testing on a little 9-inch tube that has a different neck connector and different values, but it works just as well. The biggest the biggest difficulty is the horizontal yoke impedance, in particular its inductance. The higher that inductance, the harder it is to drive and the higher voltages I need. Basically, my silicon carbide MOSFET that I'm using can handle extremely high currents, but it's limited in voltage. It can only do 1700 volts, which is quite a bit higher than the 1000 volts most run at. But
Yeah.
as you increase the horizontal frequency, you get less time. The higher frequency timings have less time to retrace, so less black area between the right screen as it flies over back to the left again. And so you need higher voltages, and
Right.
so that the higher the inductance, the higher the voltages get as you increase the frequency. So low inductances are always desirable for trying to run really high resolutions.
Yeah, and so what you're speaking to, the difference there is like vertically on a CRT, we all know it's going, 60 frames just about right under that per second on the scrolling, but horizontally it's going
So
completely
much
at
faster.
another level. It's like light speed,
Yep.
difference. And so that's what I thought was really cool that Bob brought it up, and it's an interesting point that, yeah, people want to think of it would just be so easy to flip the orientation of a CRT from like Tate mode on just like the vertical and horizontal scans right there. And it's like you're trying to say, I've retrofitted my tube so it can handle this crazy different swings in usage. So that makes more sense as to why it's kind of unfeasible to
Yep.
have it do both on both sides, right?
Yep. There are tubes that do support that. One example is vector monitors. They have
Okay, yeah.
identical horizontal and vertical windings, but they don't even a vector monitor does not have the bandwidth to do a raster scan. Like if you were to try to take like a Vectrex tube and display 240p video on it, it would not work. Likewise, there are what oscilloscopes do is they use electrostatic deflection rather than magnetic deflection. They use plates, and the plates can be discharged and charged much more rapidly than a magnetic field can be created or reversed or whatever. But the downside of electrostatic deflection is it's really hard to get really sharp deflection, like really wide angles. So most electrostatic tubes are very small, like like an old school oscilloscope will be a small screen and very long. So consumer TVs don't do that because they want to be really big and really short front to back.
Yeah. Yeah, yeah, because they don't want. I mean, they were big enough. So what about like the size on there? You said and you do work with a variety of tubes. So is is the idea that this thing will work between like what's the ideal sizes kind of for this? Is it going to be a wide range?
Yeah, yeah. So uh, generally because of the limitations of BJTs, you'll almost always see the original design runs at most, 1,000 to 1,200 volts on that horizontal. So when TVs got bigger, they mostly increased the current needed rather than the voltage. So that basically there is a level of sensitivity of the horizontal deflection as well, besides that inductance. And the sensitivity is how many amps it takes to get to one side. Bigger TVs will have decreased sensitivity, so I need more current, but that's easier for me to handle. My silicon carbide MOSFET is way overrated for current already, so it can pretty much scale up to any. I haven't looked at like bigger than 29-inch tubes, but there's no reason it can't scale to an arbitrary size tube. Likewise, small tubes should work.
Yeah.
I haven't tested like a camcorder CRT or anything like that, but I don't know why it wouldn't work.
Sorry, Lewis, I didn't mean to keep going there, but if you do have any questions,
no, it's good.
here,
Sorry,
too.
pardon me. You guys were
No,
getting
I did. I mean, I do have a couple of other things, but
I mean,
yeah,
go
if
for
you
it.
have
Sorry,
anything-
because I'm sort of at this stage. This is where the point where like, look, I can repair CRTs. I know what's going on. I know a lot of what you're talking about, and I'm just fascinated to listen. And I know a lot of people when they also are maybe like,
I also
we're not
wanted to just
engineers, but we're just like, dang, that's great. So anyway, go ahead, Steve.
Yeah, no, just like bringing it back to a spot where people too can think about kind of what this could lead to. So you're, I would feel like then if you're using, from what I could understand, then it'd be much more precise for things like making your adjustments then on your tube for things like obviously geometry, right? And so you can dial things in even better than what you would be limited to, even on probably up to a point on a lot of the professional level equipment.
Right. So I chose a little bit different design than most like PVMs. So basically for my vertical, for example, I have software that can pick every single line's position. So within some limitations of how fast the yoke lets me move, but I can choose, right? I have a little software that I have a lookup table that says on scanline X, I want it to be X amount of current. And so that corresponds to a particular position. So I could go in and I could individually place every scan line vertically where I wanted, right? I could scan in any direction, but so I can, I'm not sure how to best expose this to calibration to the user yet. Currently what I have is I just have a simple, my geometry is a straight ramp. It looks like a sawtooth wave when it's scanning from top to bottom, and then it goes back to top. And then I have one parameter that is I believe a tangent function that basically squishes the top and bottom relative to the center. So I just have a single linearity control, but it could be arbitrarily complicated, right? It could be like a zone on top and bottom. It could be 4 zones. It could be you could aim a webcam at the CRT and have it auto calibrate or something. It would, there's a lot of options there that just require a lot of software work.
Right. Yeah, that's what I was wondering.
Yeah.
I like
for
that.
Horizontal, it's not quite as good, but yeah. What is your question?
I like Thomas. Sorry, I sort of taken a step back and thinking you seem to have fairly well thought out thoughts on technically where this could go, and even a little bit, what it might mean for people already. We've talked about that. How much have you, I guess you've thought through the technical solution. How much have you sort of thought through what this could mean, and or do you try to sort of like, I'll just focus on doing this today. I won't worry about big things. Or have you do you actually have some vision of where this could take us?
Right. Like in terms of like productization or like what?
I don't know. I guess like your philosophy of this is not even a product, I guess, in a way, like, do you just focus on doing the things that need to happen to make this technically, or do you stop for a moment? Do you think, what does this mean for our hobby? What does this mean for what we're doing? What does this, because it seems like quite a drastic change is, I guess, what I'm thinking, like a pretty big thing. And I'm like, is that something you consider when you're thinking this, or do you just get on with the job and make something cool?
Well, yeah, a little bit. It is kind of primarily to solve needs that I have. Like I want my arcade monitor to run at 31 kilohertz, but I have my general philosophy from it has been to try to make it, besides making it, I've tried to make it sort of high end, and I kind of want to see how much I can push CRT technology. Like, what if you made a CRT in 2021 with 2021, silicon and software components that you didn't have access to. For example, I'm using a silicon carbide MOSFET. Another thing is the software vertical and some level of software horizontal control. Some things like PVMs didn't have fast software, so they actually had, if you look inside a PVM, there will be a bunch of I2C bus ramp generators. So there's a bunch of little tiny discrete chips. Each one can generate a ramp and do some software corrections on the ramp. And so the PVMs end up with a bunch of parameters of these dedicated ramp generators. But I've removed all of those and just replaced it with software that does the same thing. So I've kind of wanted to, I didn't really want to copy an existing monitor. I kind of wanted to kind of do a clean slate design of sorts and see what I could accomplish with modern tech.
That is really, that's like every second thread on Reddit/CRT gaming is, what do you think could happen if CRTs were made today? How would they be? Be like, okay, guys, well, guess maybe now someone's going to tell you.
This sounds to me the most realistic approach because, again, the fact that we do have tubes out there, and I know that there's somebody somewhere with a stock of maybe, I mean, that's kind of another thing I think what Lewis might have been saying is like what a lot of open source products come out and it's like, I release my design, here's the way it goes, I'll continue to work on it, but I want community help and see what happens. But do you have any kind of idea for maybe trying to go down that road of possibly entertaining the idea of a production of some run of, even if it's like you find a stack of 40 CRT tubes and you can, and they're all good the same, could you produce a small run of something like that? Is that something that, like, yeah, I mean, would that be something that is in your interest?
Yeah. So I would need to figure out what it would look like. I mean, this is of projects I've done, this would be one of the hardest to support. Because there's a lot of things that can go wrong. And so I'm not sure, I haven't decided what level I would want it to be at. If I wanted to, like, make a version that was a drop-in replacement for a particular monitor that was ready to go with the right wiring harnesses, or what that would look like. And there's lots of particular design choices that I haven't yet made. Does it have TV-like features, or is it like a monitor only? Is it going to have a bunch of little subboards, or is it going to be one big circuit board? What kind of user interface? Does it have a remote? Does it have a remote board? Does it have a computer app? How does it work? So I think there's some of those will become more apparent as I finish the parts of the design, but so a lot of that is really hard, and so I've kind of been slightly dodging the problem by ignoring it so far.
I think so too. I think it's one of those things where, I guess for you as well, Thomas, you need to decide for yourself. Because, I mean, there's one thing is to design this amazing, cool thing. Another thing is, what do you go into production with? How big that whole thing, all of a sudden now you're producing, that's a really a completely different skill set. And you may actually have that, but nevertheless, it starts to diverge from your original joy, which was, hey, I just want to get an arcade monitor.
Yeah, I just want my arcade monitor to be able to play every game.
And all of a sudden now you're flogging units and doing tech support. And I can imagine at least that's a sort of a thought that goes through your mind to balance both of those off.
Yeah, and I think I think if I do something, it will be very much in a CRT kit realm. It'll definitely be it will never be a plug and play box. It will always be somewhat of a thing that you have to you are sort of responsible for assembling yourself and responsible for the result. So I need to but hopefully I can make it really easy to use. I think there are a lot of things I could do to improve the experience. Like one thing I mentioned earlier is that I found it really frustrating. Like when chassis die currently, you have no idea, they just turn off. On mine, I have like a little serial port that like will give me the exact reason for a failure code. So you can imagine like having a little I could have a separate like a LCD module on it that would always be on and tell you what's wrong, even if the main CRT can't start up. or something like that could be really beneficial for initial setup.
Okay. Hey, was that just me, or did we have some interference
I think we
with
had
the transmission?
some transmission problem, but I was thinking, saying there's an LCD screen that could give him. You plug it into like almost a diagnostics port, right? And you can get the
Straight
reason
up
why
tell you.
it's triggering the alarm. Because I know what he means. Like if again, I work on this PVM chassis, and there's so many little different things on there, and yeah, you can have one thing causing an alarm to trip, and then an entire chassis won't turn on, or it'll partially turn on just enough to give you a tally light warning. And then how do you tell somebody they need to go in and figure out which one of those out of all those parts without some kind of easy diagnostics? That's I mean, that's a dream come true for somebody repairing stuff, because like he said, you run in, you don't know which part originally it is that's failed, and that's what a lot of time is spent trying to figure out where the problem's from.
Thomas, I was wondering how, because I want to ask you, for example, how big is the unit? People want to visualize it. How big is it? But I guess that there's always two questions here with a project like this, which is, for example, how big is it, and how big do you think it'll be eventually, without optimizing the life out of it? There's always sort of like, where is it now, and where do you reasonably think it's going to be? So how big is it right now?
Like you mean like physical size, right?
Yeah, physical size. Sorry. Yes.
Yeah. So
yes, physically, how big is it?
Currently it's a 250 centimeter long board, which is by like I think 150 is the main deflection board. So it's smaller than most actual CRT chassis, or like contemporary.
Sorry,
ones.
what were the dimensions you said again? 250 centimeters.
250 millimeters.
50 millimeters.
That makes a lot more sense.
Good catch, Lewis.
But it depends on it depends a lot. So that doesn't count. I have like several subboards that are not shown in the current video. Like I didn't have the HV flyback. Currently, that's its own PCB. So the main PCB, you have like a little flyback PCB. I have a separate. I made a new RGB circuit, so that's its own PCB. But it can be made a lot smaller than any of these, because I've not really spent a whole lot, like this time I've spent optimizing the sizes mostly to get the cost of the PCB down for my prototypes. But it's not, it could be made if, much smaller than it currently is. I've gone to using a lot of service mount parts, like my Rgb amplifier uses chip scale packages. So like they're basically a wafer, like in a little plastic blob, similar to what's in a cell phone. There are a couple parts in the high voltage that have to be big, because high voltage will jump over, gaps that are too small. So they have to be physically spaced apart. But it's I would say it would smaller than any chassis you would replace it with, or would replace.
Sure. That makes... I mean, certainly, who knows? We could be big, could be not. I understand it being optimized. Like, I can see how this could evolve. There's already a lot of projects out there where the creator kind of creates the blueprint and they're happy to put it out there, monetize it in a small way, and then others can take it up. Because this seems so massive, right? To do all that, to polish it up, to give all those features, it does seem... I don't know. How do you feel about that work? Because that's another thing that's impressing me is you're like, yeah, we could probably put in that other feature with the horizontal. It'll be fine. And I'm really like, dang, that's great. Like, I guess that happens because you've been working on it for so long. You know it so intimately. I guess you can see it all in front of you in your mind.
Yeah, I guess I'm already kind of in the polishing step in the sense that it all functions, but there's enormous amount to improve. So... like the two things I'm doing is my high voltage works, but it works really poorly. So I'm doing another rev of that design. The RGB input I'm currently working on, because one of my goals is to not use any obsolete components, right? So other than the tube, I can't solve that problem. But I don't, I'm using a newly manufactured flyback. All the chips I use are new. So there should be easy to get. I use an STM32. That's not easy to get right now.
Yeah, I was
Sure.
going to say I was going to kind of mention that it's almost good to be in more of the development planning stage right now than to even have a product really ready.
Yeah.
For anybody, almost. It's like you're better off spending this time ironing things out, honestly, than actually, having anything, because it's so hard. It's going to run into something. There's going to be something out of everything.
Yeah.
It's going to be hard to get.
But yeah, I had like I had one remaining chip. I used an RGB chip that was from a TV that's no longer made, and so that works. It worked in my demo, but it's not something I want to rely on because I've gotten, it seems like a good idea until you go to order it and then suddenly they're out of stock, or you get a bunch of relabeled Z80s that have had their tops painted, and then you're sad. So I wanted to avoid it at all costs. Which it does sometimes end up being more expensive if I do that, but it seems well worth it in the long run to have chips that I can actually buy.
I think so, yeah. Because this is the effort is to. I love the idea to replace everything we can. Like TVs aren't coming back. Every guy who's asking like, oh, why don't they just manufacture more TVs? We're like. 10 minutes
more
of YouTube.
CRTs, yeah. I mean, it's not...
Sorry, 10 minutes of YouTube will tell you can't make any more tubes.
Yeah, I mean, that's not really feasible. But the fact that this project can keep the tubes alive as long as they're able to show an image, because we're getting rid of the other parts that are going to fail, and this is just an amazing solution. I want to give you an opportunity. I mean, is there anything that, like, what is your challenges today? Like, are you just going through your process and, just continuing to iron out what you think in your design that you want to have? Or is there something like, what do you have out there that, is there anything that you're promoting for this, or anything that we can help, make available to anybody who might see this, and they can go learn more or help you? Is there any kind of thing that you need from any community? I've got a lot of probably spare tubes and parts, but everybody who has a CRT, they knows if you work on them, you got plenty of friends trying to give you them. So
yeah, I mean, one useful thing for cataloging like the tubes themselves, which is not only useful for my monitor, but it's also useful if you just want to try chassis swapping or similar, or TV repair where he's combining a tube with the TV. Measuring the horizontal and vertical inductance is the easiest way to classify tubes. Also looking at their pinout for the connector, you'll see very late 80s to like 90s monitors have kind of standardized on this one neck connector that you'll see a bunch. I don't know its name, but I know what it looks like. I'm not sure if I've ever had a name really.
You mean from the neck of the tube into the neck board? You mean
exactly.
that connector?
Yeah. Exactly. That one is actually pretty common on mid-sized TVs. But knowing the horizontal vertical inductance is a thing that is a good tell to see if the tube's going to be drop-in replacement or similar performance, or similar to something I've tested. That's a good thing to look at.
Yeah, walk us through that. You talked about that test with the inductance. Like, what does that mean? Is this like the idea is you're saying?
Yeah, you basically need a special tool called LCR meter. It's LCR is for inductance, capacitance, resistance. Unfortunately, most multimeters do not have an inductance meter, but you can also look up how to build your own or get one off AliExpress. It will probably do good enough. But you unhook the horizontal vertical windings, you measure each of them. Some people will measure resistance and try to compare with that. Measuring resistance kind of works for vertical, but it does not really work for horizontal, because for horizontal, inductance matters way, way, way more than the resistance. The resistance is basically at very high frequencies, all of the resistance is very small compared to inductance. So unfortunately, it's a little bit hard to measure. You need a special tool, but if you can do it, it's
yeah, but if you do have an LCR meter, something like, I don't know if you're familiar with this tool, but there's like a pretty decent one. I've done a little bit of a video on one. It's like the DE.
the DE5000 is actually what I use.
Yes,
so that's a good one.
Yes, that's the one I've got. So you're measuring. Now let's get straight to help this out. It's like measuring the inductance of the yoke, where the yoke has the connection going into the chassis normally. Is that right?
Yep, exactly. You would power off the chassis, let it discharge, then pull out the horizontal and vertical yoke connections and measure those, looking into the yoke.
Yeah,
put it back.
Okay. And so that's to determine if the tube could be used or not. With that data, you can work out whether possibly you can connect up.
Exactly. So just with that data and knowing if it has the exact same neck connections, like in pinout, you can move it onto another chassis, and if that matches, it will definitely run. You might still hit other issues, like maybe it won't fill the screen or something like that, but it should start up and run and behave correctly otherwise. So it gets you 90% of the way. And for my chassis, mine has a wider range that it supports, but it will tell you what the maximum frequency you can run. It's one component of, but the primary thing that I found is directly correlated to the maximum horizontal frequency you can run on a particular tube. So, like a lot of really big TV tubes, or even my little 9-inch tube that are really designed for 50 kilohertz, have very, very high inductances. So they can push 31 kilohertz, but you're really on the edge of what it can do. Whereas if you measure another monitor that's like 0.6 millihenries, then you will be able to drive easily 31 kilohertz, maybe higher.
All right, so like you're getting into some crazy stuff, like we're getting like right where you're running on to like the edge of what the technology could have even been capable of. I mean, beyond what it's stated it's what it's actually like edges of what it could do, right?
Yep. That's partially limited by the semiconductor technology I have as well. So I'm using those silicon carbide MOSFETs. They're only manufactured reasonably up to 1700 volts. If I actually switch to IGBT technology, I could go up to 2500 volts. But it becomes very difficult beyond that. So that's my main limitation.
Yeah. Well, the thought that this kind of had too in my head when you were talking about how you can adapt these tubes to do a whole lot more, I started to think about what kind of, just like in the future, what kind of things we're not even thinking about, like artists would be using CRTs because they could do crazy things of just using software to make a tube do things it was never seen to do before, right? It's switching through these different things. You just got it doing different programs where it itself just looks like a weird flowing display image. I was tickled thinking about how cool that would be, from even something completely unrelated to our video game sphere of something in the art world.
Yeah, certainly, like demo scene scaling effects, right? I can totally beat all of those. Like they can only do scanline effects. They can't move their scan lines. So you could do something pretty wild.
That's
you
could like purposely.
Yeah. The extra software flexibility gives a lot of that. I will say I will give you a couple of limitations and stuff that I can't do. Right? I've already discussed the auto flipping is hard. Doing like name co-rotation is hard.
Yeah.
Not impossible, because it just involves switching 1700 volt mode. So I'd have to put more expensive MOSFETs on there to do it. It's something I can do. It's just not immediately interesting to me. I can't fix your CRTs, like the pitch of the aperture grill or dot mask or shadow mask or whatever it has. So eventually, if you run at too high resolution, that's going to be a limit. And I don't have currently dual or multi-focus control. So if you can't focus a dot sufficiently small, then you'll also just have a blurry picture at really high resolution. So those are ultimately the limitations of the tube. And So that's the main thing that if you were to make if you want to make a monitor in 2021, you wanted to display 4K, it would still be a struggle because you'd still have to make a really, really, really tiny aperture grill. So that would be
Oh my gosh.
We might not see CRTs. This project is not enough to make CRTs have a comeback if people are really wanting that.
Yeah. No, I think it's a perfect though way to, I mean, it's a niche audience, but this will help it because even at the niche point, it's all when you're dealing with it, like you say, arcade monitors are exponentially a better example than even PVMs and BVMs sometimes, because arcade monitors have been running most of the time for, like you say, 10, 12 hours a day nonstop. And 30 years later, and I know plenty of people that, like you said, they have a warehouse just filled with a certain type of television era because they know that tube's good and it matches right with their normal arcades. So just the idea of there's still a lot of tubes out there because, again, it's not an easy thing to break down. So most of the time, even in the ones that were sent off, there's still some out there. And I think there's enough of that to really probably sustain this unless they all just disappear. But I don't think, there'll always be some, at least around, I feel like, our lifetime tubes.
Yeah.
Thomas, I'm going to ask you a similar question again, but from the question is, and what is it like now, and what do you hope it'll be in the future? What do you expect? What does it cost you right now, I guess, to build this thing, as you're developing it? And what are you hoping that someone would be able to put it together, a kit together one day that would be worth?
So to build mine right now, I never really did a full BOM cost of everything. It's probably $1,000 or so of parts to get one manufactured right now. That's that's obviously with being low volume PCB production that's counted in there, and my extremely not conservative choice of parts. I kind of overspec everything because it's but I think you could it could be down into the hundreds of dollars range would be practical to bring it down. There's a huge amount of cost optimization that can be done. So one difficulty when I've been researching old designs, right? One thing I have looked at is I've looked at all sorts of schematics for older monitors to kind of get inspiration. I didn't end up using all of them, but I didn't. A lot of times I went there and I disregarded the design because I hated it. But one thing you'll see is that a lot of them will be very difficult to understand is because they've been super, super cost optimized. Like, CRT TVs, were sold color ones for like 50 years. And so they've had 50 years of scraping every penny they possibly could out. And so you'll see lots of weird stuff, lots of parts serving multiple purposes. You'll see just they have shaved every penny they can to make TVs at an incredibly cheap price point that everyone could afford. But
they do. They shave every penny. That's what you go see. They'll cut, like, the neckboard's been cut out of the chassis PCB. The PCB. They're even just cutting the same big board and designing a lot of stuff with empty spots and just jumpers. Yeah.
In my case, because I've not been
price.
Targeting the very cheap price point just because I want to, I don't know. I feel like if people want a really, really cheap piece, chassis, they will just use the existing one because I can't beat that price.
Right. You might as well. Right.
I really wanted to build something that kind of, had a purpose in life. It was actually better than it was out there. So I've kind of, aimed to at least try to make it better than what I could just get already.
I think it's a nice thing because not only is it's not just like a technological solution, but it also is like a bit of hope. Actually, we love these things. We all love these things. And there's now a new idea out there. And it's not, we're still working on it. There's good minds working on it. It's coming here. But this idea that actually this is not, what we love might not actually have to be landfill. and that's cool too. I like that idea. What are we gonna do with it?
Yeah, I think that I was
yep,
going to say, Lewis, I think that this is probably a good spot. Yeah, like, so I know we'll put a copy of the link to your video in the video description here. Do you, and then you have a GitHub page, right?
Yeah, so the GitHub repository is updated like real time. So as I do new stuff, it'll get stuff pushed there all the time. But it's not it's something you can definitely follow along with, and I'd really like to write better documentation in there. Kind of I've tried to put some amount, but it's still very basic, and it will be changing as I continue to change things, right? So, I can't recommend building it from the current state it is. I mean, if you know what you're doing and you are prepared for the consequences of building something that's very much a work in progress, go ahead. But I at least have that. I doing a sort of blog about my progress, given that there's a lot of interest now, is something maybe I could also consider doing. I just haven't quite got stuff together yet to do that.
Well, is it Thomas? You mentioned in Bob's podcast that there were some very particular areas that you needed help on. You're like, hey, this area could need refining, and they're all very, very specialized sort of things. Is that the state of the project right now? That really, to get involved, people genuinely want to help out. They want to, they love this idea. It's just some work has to happen first before it gets somewhere, and that it's really just specialized help that you need right now.
Yeah, that's unfortunately the case. Like I would. That's why I haven't it's I know if I had when I posted on earlier, I had people replying, set up a Patreon and I'll send you money. But that's unfortunately that doesn't really make it go faster because and that's not the hard part. I can spend a lot of money if I want and it'll still not work. So it's if people are familiar, there's some levels of non-power electronics in there, like the Rgb amplification circuits, all low voltage analog circuitry. So if someone is familiar with that and wants to, take a shot at that, that's something you can experiment with that part with rest of a normal CRT. You can do the same thing I originally did and just disconnect a component of it. So there are parts that you can do without high voltage knowledge. But there are some software pieces too. If you want to take a go at the software that does the calibration, or you want to make a GUI front end that talks to serial protocol and gives you a nice, an Android app that does serial, or like a computer app, that would be something that would be interesting to work on. That doesn't involve power electronics. For some of those, I would really like to be able to give someone a copy of the working board to start working on, though, and I don't really have it at that point yet.
Yeah. Sure. Yeah. When did you put out this video, Thomas? When was
it was about 3 months ago now, I think. The video was, I had a live demo at Vintage Computer Festival West, which is inside the Computer History Museum in Mountain View, California. And I had a lot of interest there. So I kind of, after I took my demo set up back, I set up in my living room table and did a video version of the same demo. So that's what the video that you see at Vimeo is showing. So I do have a little bit more working since that video. I'll probably do another video update soon if I have something to do, or maybe I'll transition to a written blog post format. I'm not sure it'll be more convenient, but
that's all right. However you do. I know people are fascinated by it, but of course, look, your work and how you feel is number one.
Yeah.
We're kind of big fans of that. Like, don't put out more than you feel you have to, even though, every fanboy's there.
Right.
There's going to be a lot of people. Yeah, there's going to be a lot of people interested in this. So I think the best thing to do is definitely direct them to, if they want to follow along with the project, to follow along through, at least for now, the updates on the GitHub page that you have, right?
Yep.
And then if you're into specialty stuff, I think that we talked about, if you do have the LCR meter and you want to test yoke windings, I'm sure that data can be saved, and that will be helpful down the road from now. But yeah, I mean, thanks again. This has been an awesome opportunity for us to come on. I guess I do one more question before we get out of here. How did your presentation come about? Because like I said, I didn't have any idea about it. Did you like tell somebody you'd been working on this that you knew from this computer thing, or did you just show up with it?
So
say,
basically,
I've
I've had the project working for like 2 years, and basically the week I kind of worked off and on it, and like some people I know in person had been, knew I was working on it and kind of been bugging me about it for a while, and I finally decided Vintage Computer Festival was coming up, and I had nothing to bring as a presentation. I often bring like old computers, but I've done that enough times. So I decided this would be the thing, and so basically the week before I went really hard on it, and I cut the acrylic case for it and everything, like the night before. Like the glue is still, I could smell it when I was bringing it in. And so I kind of made that my deadline to get something together. And so, and then I posted a video on Twitter, and it got some popularity, like right, because people posted it in the context of Vintage Computer Festival. And it also got an additional amount of popularity recently. I think it got posted around on Facebook groups and the like. So I don't have any insight on what makes it popular at any given time. I guess I probably do. I can probably go look at the video analytics and figure out where some of the hits have been coming from. But regardless,
that's the last time I saw it.
Yeah,
was
it's
reposted.
It is motivating to see a lot of people interested in the project. That does help. But it's I do like to. I do want it to be a better for showing something. I want to describe it. It is in a not quite the state I would like it to be in, to really show it off as a finished product. It is not that right now, but I think it is good to at least have. I try to keep at least the work in progress up to date, and let people see what's happening right now.
Great.
Fair enough. Nice.
Well, yeah, Lewis, what do you think? We think we should.
Yeah,
about
Thomas,
an hour
we
right
know
now.
you're on break,
Yeah.
so we won't want to hold you up too much.
Yeah,
But,
thanks again for your time. Absolutely, I'll let Lewis close us out, but I'll be following the project, and I think that again, if you're interested, definitely follow the project, and you always got a place here. You can come talk about cathode ray stuff and your updates however many times you want. We do this show, and this is a perfect place. I think if you want to talk to people who are definitely interested in it, you're welcome back anytime.
Yeah, thank you for having me.
Thanks, Thomas. And thanks. Look, buddy, Steve and I have been doing this podcast for only a short time, and you're the first guest we've had on. So we understand if this was confusing. We were working it out for the first time, trying to make
Any
it so we
technical
appreciate
difficulties, we might have some on this episode, but it's all right. We're ironing it out, and it'll get better. We're doing it.
We appreciate you talking to us two weirdos.
Yeah, thank you.
Who are trying to work it out. Thank you very much for your time. I appreciate that, mate.
Yep, thank you.
All right.
All right. Bye, everybody.